Hello everyone. So welcome back to the last part of 6th unit. So in this video we have to study the concept of multiplexing and demultiplexing. So first we need to understand what is a multiplexer and what is a demultiplexer. So the multiplexer is the combinational circuit in which many inputs are applied to generate a one input. Means in multiplexer the number of inputs are applied to the mux and the output will be only one. So in multiplexer there are three types of multiplexer that we have to study in our syllabus. So the first type of multiplexer is 2 has to 1 mux, second is a 4 has to 1 mux, and third one is a 8 has to 1 mux. So we have to study how to represent the 2 has to 1 mux, 4 has to 1 mux and 8 has to 1 mux. So in order to consider the 2 has to 1 mux, so here 2 means 2 input and 1 means 1 output. So along with input and output we have to consider the select line. Now how to calculate the select line? So the formula to calculate the number of select lines is equal to 2 raised to n. So in this case n is the number of select line. So how to get it the select lines? So 2 raised to n. So the multiplexer is 2. So we have to consider 2 raised to n is equal to 2. So if we place n as a 1, then 2 raised to 1 is equal to 2. So the select line will be only 1. So we have to implement this 2 has to 1 mux by using a gates. So here first we have to consider the select line and then we have to consider a output. So the select line can be represented with S0. So the input of select line it should be 0 or 1, and in output column we have to consider the number of inputs. So number of inputs are D0 and D1. So this equation we have to consider as a SOP form. So we have to write the equation as a D0 and we have to take the complement of 0, that is a S0 bar, and plus D1 into S0. So this equation we can implement by using a gates. So first term is a D0 into S0 bar. So here we can provide D0 directly to the AND gate, and for S0 we have to consider NOT gate. So AND gate will take the multiplication of two inputs, that is a D0 into S0 bar, and second one is a D1 into S0. So D1 into S0, and the output of two NAND gates can be combined by using OR gate. So in this way we can represent the 2 has to 1 mux. So similarly we can represent the 4 has to 1 mux. So according to the formula, in 4 has to 1 mux, 2 raised to n is equal to 4. That is a 2 select lines are there. So the number of inputs are 4, output is 1, and select line are 2. So to represent the K-map, first we have to write the select line. So the select lines are S0 and S1 and output as a 1. So for S0 and S1 we have to write the standard digits 01, 01, 00, 11. So output may be number of inputs. So D0, D1, D2 and D3, and we can write the equation. So how to write equation? So D0 into S0 bar S1 bar. Why? Because S0 also 0, S1 also 0. So we have to take the complement of it. So similarly we can represent the truth table by using a equation, and that equation can be implemented by using a gates. So for multiplication we can use a AND gate, and for addition we can implement a OR gate. And third one is a 8 has to 1 mux. So in 8 has to 1 mux, the 8 inputs are there, 1 output is there, and according to formula 3 select lines should be there. So also we can mention the truth table of 8 has to 1 mux. So there are 3 select lines, S0, S1, S2. So we can represent the select line by using digits, that is 01, 01, 00, 11 like this, 4 times 0, 4 times 1, and in output column we can put a number of inputs, that is a D0 to D7. So depending on the input we can write the equation of Y. Okay. So how to solve the equations, how to solve the examples by using multiplexer. So here we can consider some simple equations. So the equation number 1, example number 1 is implement the given function by using 8 has to 1 mux, and the numbers are 0, 1, 3 and 5. So this equation we have to implement by using 8 has to 1 mux. So first we have to draw the 8 has to 1 mux diagram. So it consists of D0 to D7 inputs, Y as a single output, and S2, S1, S0 are the 3 select lines. So whatever the number provided in equation, that is 0, 1, 3 and 5. So in multiplexer we have to consider D0, D1, D3 and D5. So it is a SOP form, so that we have to connect these 4 numbers to the logic 1. And what are the remaining number that we have to connect to the logic 0. So it is a SOP form, that's why we can consider output as a 1. So D0, D1, D3 and D5 we have to connect to logic 1 and others are to the logic 0. So similar example is there. Again the numbers are 0, 2 and 6. So D0, D2 and D6 are connected to logic 1 and others are to the logic 0. So in this way we can implement the 8 has to 1 mux. So along with this we have to design the function by using 4 has to 1 mux also. So how to implement the given function by using 4 has to 1 mux. So here the one example is provided. So the input variables are 3 and the cell numbers are 1, 2, 4 and 7. So the input variables are 3. So we can easily identify it is a 8 has to 1 mux, because in 8 has to 1 mux the number of inputs are 8. So the according to the cell number, so the maximum cell number is 7. So based on this cell number 7 we can consider this is a 8 has to 1 mux example, and this 8 has to 1 example we have to implement by using a 4 has to 1 mux. Now how to implement it? First we have to draw this type of table. So in order to draw this type of table, first we have to consider the input variables. So we can write as a select line A, B and C. So first we need to write the ABC. So we can represent the digit as a 0, 1, 0, 1, 0, 1, 0, 1, B as a 0, 0, 1, 1, 0, 1, 1, A as a 4 times 0, 4 times 1. So we know this example is 8 has to 1 mux. So at the left side we have to write a 8 has to 1 mux and the number of input in 8 has to 1, that is a D0 to D7. And now we have to implement this 8 has to 1 mux by using 4 has to 1 mux. So we have to make a groups and like D0, D1. So for D0 and D1 we can make a one group, that is a D0, D2, D3 make a one group, D1, D4, D5 make a group, D2, D6, D7 make a one group, D3. So after forming a group we have to write a function. Now how to write a function? So in function the numbers are 1, 2, 4 and 7. So it is a 8 has to 1 mux. So whatever the 8 has to 1 mux inputs, that is a D1, D2, D4 and D7. So at this place we have to put a 1, and for others we have to put a 0. So how to implement by using 4 has to 1 mux? So to write the equation we have to consider the function and the last column. So in function is F and last column is C. So we have to consider group wise. So groups are D0, D1, D2 and D3. So in D0 as C is 0, function also 0. If C is 1, function also 1. So is there any change? No. So we have to put a C. So in D1 group, if C is 0, function is 1. If C is 1, function is 0. Then we have to put a, so the C and function are the complement of each other. Then we have to make a C bar. Then next also complement C bar. Then last D3 also same. Then we have to put a C. And to represent 4 has to 1 mux, we have to consider 4 input, 2 select line and 1 output. So the D1 and D3 are connected to the C, and D0 and D3 connected to C, and D1 and D3 is connected to C bar. So same we can implement the example by using 8:1 mux. So similar to this, we have to first identify, so it is a 4 variables and the maximum cell number is 15. So it is a 16:1 mux. So we have to first draw the table. So for table first we need to draw the select lines, it is A, B, C, D, and we have to draw the standard digit. So as it is 16:1, we have to put D0 to D15. We have to implement this by using 8:1 mux. So we can make a group of 2, so D0 to D7, and always we have to compare our function. So for function, whatever the cell numbers, that we have to mark a 1s, other are 0. So for comparing, we have to always compare the function with last column. So D and function we have to compare. So if there is no change, we have to put D. If the function is opposite, we have to put D0. If the function, so here in D3, if the D is 0, function is 0. If D is 1, function also 0. So we have to put, so if the 2 zeros are there, we have to put 0. In function, if the 2 ones are there, we have to put a 1. In function same is there, then we have to put as it is. If complement is there, then we have to put a complement. So in this way we can represent the multiplexer. So in demultiplexer, the input is only 1 and output is there are multiple outputs. So same as to the multiplexer, we can design demultiplexer also. So in demultiplexer there are 3 types. One has to 2 mux, second is 1 has to 4 mux, and third one is 1 has to 8 mux. So similar to multiplexer, we can also design the demultiplexer by using the truth tables. So here we can represent the 1 has to 2 demux, 1 has to 4 demux, and 1 has to 8 demux. So to write a truth table, we can consider we can consider the select line and the output. So there are 2 outputs, so we can consider y1 and y2. So how to represent it? By using input as a data lines, so y1 and y0. So similar, in 4:1 demux, the 2 select lines are there and 4 output lines are there. So the select line we can represent with a digit and the output y. So we have to first y0 as a D, others are 0. Then y1, so where is y1? So at second D, others are 0. y3 at third place D, y3 at last D. So in this way we can also design the 1:8 mux. So how to implement the given equation by using 1:8 mux? So the equation consists of number 0, 1, 3, 6 and 7. So whatever the numbers 0, 1, 3, 6 and 7, so at this number, that number we have to provide it to the OR gate. So we know the representation of K map. So whatever the 0 position in K map, so the position of 0 is A bar, B bar, C bar. Position of 1 is A bar, B bar, C, like this. So that position is provided to the OR gate. So that will be the final function. So thank you. So here we can conclude the 6th unit. Thank you.